let's start the recording actually. And so I will actually add a note that on there will be no live lecture on. I'll maybe add something pre-recorded, maybe some instructions on Kotlin or something like that, something small. All right, so note. Right. On what is that? Thursday, 6th, right? March 6th of March. Right. Do the quiz for that day. Eventually, right? Until Monday. All right. Okay. Where is it? Okay. So today is, well, I think the last of our, like, sort of mostly theoretical lectures. I think we have still, well, abstract, I think I'm going to skip the abstract data types and we'll move on to OOP already. So once we have more time to spend on Kotlin and Rust and Go, and also maybe we'll do also a recap of SQL as well. So 4 languages in about, what, month and a half, right? Kind of quick, right? So we covered subprograms, so OOP, right? We all use OOP in C++, right? In Java, and let me go to GitHub. All right, let's see what authentication. Come on, unlock. Yes, but they're not finished yet, unfortunately. I apologize. So maybe on Thursday, well, you have time off, right? You can look at the results. But overall, I was pretty pleased, right? So, like, my general vibe, so to say, is that it's good, right? But you know, there will be some difference in grades, of course, right? I'm sure there'll be some 10s, maybe some 6s, some 7s, some 9s, right? I didn't see anything really bad. Yeah. So, all right. Not too many. I don't think too many 6s, maybe. Right. No. So, all right. Code space is now running. Okay, that's good. Yeah.
So now we're going to learn Kotlin and SQL.
Yes. You have, so questions now. I mentioned you had some course where you took SQL. How much SQL have you learned actually?
Briefly.
Very briefly, right?
It was okay. Just a week.
Just a week. All right.
Learned about joins and
That's it. But you go to joins, right?
joins is like, yeah, the math.
Like store procedures, things like that. You didn't get that far, right? But joins is good. Group by. Did you get group by? Yeah, just group by a little bit, right? Some aggregations, things like that, maybe a little bit, right? So yeah, and in fact, SQL is actually in a way, it's one of those things that you learn. You can learn it in maybe I think in a couple of weeks. It was actually made, you know, well, this lecture I will give you in a couple of weeks in any ways. But SQL, you learn the basics, then of course, you start using it. You can improve, just like table tennis or I don't know, chess or Go. Right, you can improve it your whole life. It's useful. It's one of the, so in a way I would not want to drop it completely because it's so useful. After probably the most useful thing you can learn as far as longevity, right? Well, I guess C counts for that too. In 1970s language, which you can still use today and is still used everywhere, basically, right? So kind of like one of these things I I wish I learned earlier when I was like, I don't know, 18, not, not 25. So
And then after that, Golang.
Go on Rust. We'll finish with Rust. Right.
Well, I'm asking, I have an idea, I mean, it's
Yeah.
up for discussion.
Yeah.
It would be kind of cool if we replaced Rust with like building a full stack program.
Okay.
Because we can join Kotlin,
Yes.
Golang, and SQL
Yes.
into a very nice full stack program.
Okay.
And I think that would be very beneficial to like.
We can. It's completely open. Yeah. Because in fact, yeah, we're open. Rust in some ways is very hard. It's probably the hardest one. All right. And that doesn't mean it's bad, right? But we could. This is something I'm open for discussion, right? Because I'm going to skip a couple of these lectures, which are like very theoretical, right? So today I think the OOP one, and that's it. I think I'm not going to do any more. Yeah, there's not going to be any more. Yeah, that's it basically, right? So we gain a couple of weeks basically. So we'll have some room. I've had this request before, right? And actually I brought it up to our administration that we would, you want to have some full stack, sort of like full stack experience, right? And it'd be useful to do that, right? Well, if you want to do full stack, of course, then we have to, if you want really full stack, you have to have some JavaScript, right? That's kind of like that. Right.
But front-end with Kotlin is possible, right?
Yeah, it's possible. Yeah, it's possible. Right. But of course, most things, there's things you can do, right, and there's things you should do, right, like But yeah, so very good point, and I'm seriously open to changing that because it's not set in stone, right? So, all right. So let's get started on this. I guess it's the last kind of theoretical lecture, but hopefully I'll have some examples too, right? So we'll do an OOP. Again, we done C++. All of you have some experience already, right? And so, of course, right, we have the basic idea, right? The class as a blueprint and objects as instance of this class. It's a one big thing. But let's go back maybe a little bit in history, right? So history actually is this mention, actually there's Simula 67, I believe, actually there was Simula 1, I believe, right? In fact, right, in Simula 1, I believe Simula 1 was in 1962, I believe that was the case. Again, I have to start. I want, or commit. Oh no, okay. Why don't I have to the name for it? Yeah, so Simula 1 from 1960s. Yeah, so these were, I think, Swedish languages, right? Kind of big influence, right? Early influence, right? Idea of the class and objects, right? And then Smalltalk, very influential. Smalltalk was developed by somebody called Alan Key, I believe, right? Alan Key. Smalltalk was developed by Alan, I think Alan Key, right? Xerox PARC. And I've told you before the story of Xerox PARC. What's the story there?
I don't think you have told.
I haven't told. So Xerox, you know what the company is Xerox, right? Still around. Excuse me? Printers, you're right. So, and if you look at their, kind of funny, right? If you look at their stock price, right? Xerox stock price, right?
In the 90s.
Yeah, so, so here's the story, right? So you look at their, we don't care about the price, of course, right? Price is not important. It's even worse than I thought. It's only 800 million. It was 2 billion the last time I checked couple months ago. So they've dropped actually quite heavily. They're now, well, let me see, 6 months. It's really that bad. Yeah, I looked around here, and now it's about half of that. Right, so less than a billion, which is like less than what Printify or, it's like nothing these days. Right? What's a billion these days, right? So, but the story goes that in 1960s, right, they were literally printing money due to what? Due to what? They were like Google, Meta, what's the name, Apple, Microsoft combined in terms of making money. They had, in those days, they had capitalization of like of a billion, which is a lot of money then, or even more. So what was it? How were they making money? Somebody mentioned printers, but that's 1960s. What were they doing? What do you think? Fax machines came later, 80s. 70s maybe, but 80s, right? So, 1960s, right? I guess I haven't told you a story this, right? Who has a good guess? Like, you kind of imagine how could they had almost a monopoly, right? They were just literally destroying the competition. What product were they making money with? Phones? Okay, good guess. Well, that's AT&T had a monopoly on phones, actually. That's, yes, copiers. So they made something 1957 Xerox, right? I'll show you what it looks like. Come on, come on. This look like this. Vintage. Or you can buy one. No, that's a paperback from Xerox. But Xerox first photocopier, first copier, which was this 914. 914. Yeah, 914, this thing here, right? And this thing was just amazing, basically, because they had nothing before that. They had nothing useful. I mean, they had some different technologies, right, to copying things, right? But in an office setting in America, in Europe, right, pretty much anywhere you need, you know, it was just amazing, right? It didn't look so, you know, just like normal copier, a little bigger, right? It completely revolutionized this. So during 60s, they just couldn't make them enough of them, right? Of course, they made upgrades and so on, because, you know, you gain amazing productivity, right? You know, computers are not widespread, but you need to copy things, right? All the papers, you know, piles of paper. A kind of funny story, well, I digress about the story, is I think had standard equipment, one piece of equipment which came with it. Do you know what came with it? Like unexpected, or maybe expected. Not something technical, but something very much needed. Ink is of course needed, yes. Excuse me? Of course, yeah. Well, no, yeah. I think you had to lease it. Well, I think you had to first lease it, just like computers. But you had to actually buy it. How much it cost? I forgot. It cost price. It cost like 300 pounds. Yeah, but purchase price was 30,000. Amazing. So you wanted to rent it. You were renting, but that's not. But it had something very interesting with it, right? Kind of, you know, slight downside to this copier. Any more? Yes. Did you know this or did you guess?
Well, to be honest, I heard from someone.
Yeah.
else
So yeah.
in the class.
Okay. Fire extinguisher, right? Because why? It also static electricity, right? They hadn't figured this out, right? So you could have occasional fire in the office, right? Yeah, but it's all worth it. And that thing cost $30,000 in 1957. That's like over $500,000 these days, right? Expensive, but worth it, right? So anyways, the story goes, why all this talk, right? It's all about business, and in general, what happens in life is that when a company has this amazing product, we call them cash cows, right? In economics term, actually, right? Well, of course, you start innovating, but basically you have so much money, you don't know what to do with it, right? So they built up this research center in Silicon Valley in 1970s, and they put all the smartest minds to work on it, on things, do something, right? Maybe we'll do something with it, right? So I think I mentioned this. So they came up with what? First, graphical user interface, first Smalltalk, first real OOP language, first laser printer, Ethernet, of course, networking, you name it, right? Everything was there in the 70s at Xerox, right? The only problem was they did not capitalize on it. There have been multiple documentaries on how 1979, like two guys, you know, Bill and Steve, came to Xerox, right? And, you know, they got some ideas from them, basically, right? So of course, Steve Jobs and Bill Gates, right? So, yeah, so basically, they completely blew the opportunity, right? So it's an age-old story. I think it's called, well, the process of like innovators in dilemma. There's a book on it, actually, multiple books on this idea. And I think it's something which Google's struggling right now, right? Google has the same problem. They make so much money from ads that they have problem capitalizing on LLM, on artificial intelligence. Even though all the papers, all the major research came from Google, actually, about 10 years ago, 10, 15 years ago. All the groundwork, most of the groundwork is done by Google, right? OpenAI and Microsoft sort of like came afterwards, right, on it, right? So it's kind of interesting, right? So that story, it repeats everywhere in any industry, right? You become big and you don't really want to, you are afraid to change. I mean, they could have been big in, they made computers, they make laser printers still, they make it, right? But they could not capitalize on it, right? So big problem for them. I mean, for them, but of course, we did gain a lot of crucial technology from this 1970s, from this, you know, when they didn't know what to do with money, right? They don't know how what to do with it, but of course other people, how many, I don't know how many, so many companies started from this lab, right? People, okay, 4 or 5 people do something cool, right? I think Tricom, I don't know, it's maybe even Cisco, Sun Computers, which is bought by Oracle, many computers, many computer companies have started from them. So yeah, okay, so that's a story of dangers of innovation, right, and how, right, Xerox PARC, right. So Smalltalk is kind of like this too, right? You probably have not used Smalltalk. I don't think anybody uses Smalltalk these days. It's not even like COBOL or Fortran, right? Maybe some few of, some, I wouldn't say crazy people, but just basic people who have, nothing. It's not really well supported these days, right? So that was the thing. So, but basically, there are some ideas. You want to have abstract data types, right? Because you want to encapsulate the data and functions, right? Probably you want inheritance, right? And you want to bind method calls to methods. Basically, right? So here's the story actually. So you can see Simula, right? OOP, Smalltalk. Smalltalk was 72 actually even, right? But there's a little prologue there, right? But that's not OOP, of course. This is just like a big picture. So module 2, Object Pascal, it's crazy. Objective-C, right? Do you know who used to use Objective-C and who is using Objective-C still? Maybe a little bit. Do you know? No, different big company. The fruit company.
Apple.
Yeah, Apple. Yeah, not banana, but Apple. Yeah. So Objective-C, of course, was the big one. C++, which you all now love, and you love that. No one love it, right? Yeah. Eiffel. Right, a kind of weird language. There's other 95 actually, right? So these are the object-oriented versions, right? In fact, the big sort of like the OOP, I wouldn't say granddaddy, but the one which really brought. I mean, C++ made it is OOP, right? However, as we know, if you really want to, C++ does not force you to write OOP. In fact, about 30 some years ago, I wrote C++ just like C. I didn't know better. I didn't really care about OOP at the time, right? I just needed something working, right, for some experiments, right? And so I wrote just like I would write C, right? And you can still do this, right? It's a multi-paradigm language, right? But Java is basically OOP all the way, right? Pretty much everywhere, right? So kind of force, you have no choice basically. C# is kind of like that too, I guess, right? So question might be why do we need anything besides functional programming, right? Closure, kind of cool, right? We have imperative programming. So what's imperative programming? Classical programming, you write loops, you have things from top, you go down, right? You have some functions maybe, right? But you just do stuff, maybe put some functions, right? But it's not really there are no higher level constructions basically, right? So the need for OOP, why it's everywhere these days, right? Again, sometimes maybe not necessarily, why maybe you don't need it, but it's still there, is that the productivity pressure, right? It's a way of managing larger projects, right? Many places, right, this object-oriented approach lets us sort of combine work of many people. In fact, in theory, right, you have multiple teams working on a big project using these OOP principles, and they wouldn't even have theoretically only their team leads on the managers who have to meet, right? You don't really want to, 100, 200, 300 person products, right? You could produce them using OOP principles. I mean, you could produce them using non-OOP principles, but that got really hard in 1960s, 1970s. Big projects, they had some problems, right? So yeah, an idea, of course, there's a couple of good ideas. You can design modified data types. This little black box idea of black box, right? You don't necessarily have to know what's inside the black box, but you can use it. You can use the methods, right? You have the data, right? So very kind of powerful ideas, right? So we need ADT. Well, I wouldn't say needed, but it's, of course, you have, so class is sort of like ADT, right? Abstract data type. This means it's an idea. Again, if those who have taken philosophy, you have taken philosophies anywhere, right? Plato, Platons, right? idea of ideals. He had this big idea that there's a, concrete triangle, right? And then there's this idea of a triangle, like a perfect triangle somewhere, in some other multiverse, basically, right? So this thing's still around. I mean, it's a very influential idea from philosophy, right? This idea there's some perfect sort of like an abstraction, right? So in OOP, right, we have these classes serve as these abstract data types. So, and of course, instances, we call them objects, right? So we have the derivation, right? We can have subclasses, right? Right. So how about methods, right? We call them member functions sometimes, right? Sometimes called also methods, also called member functions, right? Member functions, come on, I don't want to type all day. Member functions, come on, why doesn't do anything? AI is broken today. I'll do everything myself. Right. Yeah, it's not completion sys, and what else? No, it should be working. I don't know what's up. Okay, yeah. So there are a couple other things that, of course, if you don't need something as heavy as a class, you use something called interface, right? So what's an interface? Basically, in most languages, what do you call what's an interface? Well, yeah, it's kind of like a class light, basically, right? It's more doesn't really have everything within the class, right? Kind of like it's used for something called programming by contract. You say, okay, what should be done, right? Maybe there's you define some classes, maybe some data. I mean, some methods, some data, right? And then if you inherit this, right? If you're using this interface, and you could be using 5 interfaces in a OP language such as Kotlin, right? You have to implement them, right? You say, okay, I have to do this, right? So you inherit some like, I don't know, I/O interface for networking, right? You have to do it, right? You promised yourself, right? And then you have to make it, basically. And it has well-defined, inputs, outputs, basically, strong typing, right? What comes in, what comes out, and you have to do it, basically. So it's kind of like putting yourself in a structure, right? Kind of like this.
But it never really used that in practice.
Yeah, it's a thing. Okay, well, depends on the project. Depends on the project, of course. If you're doing yourself, I mean, you will waste more. Well, maybe now with AI tools, you could probably do it right now, no problem, right? But still, if you're doing for yourself something small, and you don't have any supervisor, right? Right? You can skip him, right? Just do whatever you want, right? But as you have more, like you have to make something similar, right? You have similar ideas, like similar needs. Maybe you need like, I don't know, different web scrapers, for example, just a stupid example. Web scraper, right? You have some interface, what to do, right? But you have, different implementations, right? So you say, okay, you define this interface. Again, we'll see this in Kotlin, and again, it's very, again, nobody's holding a gun to your head, right? But if you're working in a larger project, right, you will see them, right? So, what else? So subprograms, right? So of course, so ADT, right? Classical example. Let's do it in Python. Of course, Python supports OOP, right? So we have this ADT, right? A class stack, right? Data. We define this data structure, right? And of course, we have some methods, right? And then we have a extremely trivial implementation, right? Because we already have everything built in, right? You can use a list, right? But the core idea, of course, what's the core idea of ADT is that, right, the implementation, right? As a user, you don't have to worry about. You should not worry about this, right? Again, you only worry that what's publicly available. You worry about these things, right? Is empty, push, pop, peak, size, and it's up to maybe your friend, maybe yourself, maybe your some other library developer, maybe your colleagues, right? To make it correct, basically, to make it fast, right? They could be using something really stupid, maybe some really bad data structure underneath, right? That's their problem, right? You want to use it. If as a user, right, of this ADT, of this stack, right, you care about the performance, right? So here, yeah, it's probably okay, right? Again, nothing's perfect, right? But, you have well-defined methods. It's empty, push, pop, peak, size, right? And of course, you could add some more things. Like, for example, you could define add, right? A classical way of doing OOP, right? You could overload add, right? And what do you get then? Then you can add 2 stacks with a plus sign, right? Yeah, so something like that. we could maybe do that. Let's take a look. So I'll have my stack. No, these are types, right? These are my classes, right? So yeah, so in Python, right? So in Python, of course, everything is class-based actually, right? So in Python, pretty much everything is based on classes, right? Yeah, yeah, class inside classes, of course, right? Yeah, we can have classes in fact, right? Yeah, and so on and so on and so on. We can have, right. So of course you see all this, right? You see class string, class integer, class boolean, class float, right? So these are all based on class. Even Valdis, right? String literal, right? Even strings are based on this class-based approach, right? So what does it mean? Of course, that we have methods, right, that operate on them, right, on this data, right? So so okay, let's talk about the stack. Maybe since we have time, let's have some stack. Is my stack empty? Yeah, empty. I'm going to push some values. Now I have 3, right? My size of my stack, right, is going to be, maybe I'll make this a little bigger, right, because you don't see anything probably, right? It's of course all basic stuff, right? Do you all, so peak, pop, size, pop, right, size, right? So we had 2 items. So let's define idea of adding 2 stacks, right? Again, a brief reminder what is the idea of stack, of course, is that you're not supposed to know what's inside. I mean, you only see the top, right? To me? Yeah. Last in, first out. Last in, first out, yes. So a stack of plates or stack of books or whatever, right, of stack of cards, right? So again, the implementation, what's done, again, it could be done in some other way, right? Here we have already, we sort of skipped the problem of making it, right? We have empty, right? Is empty if you have nothing, right? Maybe this actually might be comparing it to an empty list, right? We are using list here to self, right? So we hide the implementation, right? We could have used linked list or tree or something else, right? Some sort of array structure, maybe from NumPy or something, or more operations, C-type array, could be anything right here. So that's the idea that, or initialization, right? Well, maybe, of course, we could add a sequence here, right? The optional sequence, right? Empty tuple, right? We could do this. Let's modify this a little bit. Sequence, right? Is none, right? If, right? Else, right? Is list. So that would be a even better improvement, right? Classical improvement. That now we have, of course, what? We have a default parameter, right? And we can initialize. It's initialized as empty, but if you want, you can initialize with anything you want, right? And again, I think kind of cool. So let's add one more thing. So how would we add 2 stacks? That's kind of interesting. So adding 2 stacks, it's doable, but it's of course not part of the stack definition, right? It doesn't say, right, how should you add 2 stacks? I mean, just put one on top of other, I guess, right? But there could be other ways of doing it, right? Yeah, one, yeah, like this, yeah, right? It's called interleaving, right? Interleaving. But of course, so I'll add it, but of course that is of course just for heck of it, right? Since we, right? So let's add, yeah, multiplying. Well, let's add method, right? So we can use plus. So add self other, right? And so I like this interesting approach, right? So AI took the easy way, right? It basically says, right? So to do, of course, we could have used some other way of combining, for example, interleaving, yeah, right? Okay, I don't know if you want to multiply stacks. Do we want to multiply stacks? Yeah, we could. Yeah, let's define multiplication, right? So let's define multiplication, right? So this will be what? Easy, right? But not other, right? This, of course, would have to be number, right? Integer, right? Right? Number, multiplier. Multiplier, right? Come on, yeah. Of course, again, this works because list. Yeah, of course. So we are sort of again standing on the shoulders of giant list class, basically, right? Sort of like again. So we could have, of course, the approach we have taken. We could have extended list. Well, if Python would let us. I don't know if we can do this actually, right? But the idea would be if we inherit from list, we could kind of improve it. But here we kind of avoid this issue of list, right? We don't. Again, as a user, we don't have to worry about if it's list or not. Let's do it again. So now, let's make a big stack, big stack. So double stack, right? It's going to be what? My stack plus my stack, right? So my stack plus my stack. Of course, print double stack, right? Can we print actual things, right? Ah, right. So stack and stack. Okay, did I make a mistake here somewhere? Let's take a look of other items. Well, it should have worked. No, it should have worked. Self items, other items. It looks okay. Other stack, right? Yeah, it should work. I wonder why it didn't work, or did I just forget about it? Let's try this one more time. Oh, because I know why. Because my stack did not have it. I made it. Yeah, okay. What was the issue? I defined the class blueprint, but my object was created using the old blueprint, right? So it obviously did not have the new plus, right? So now it should have it, I hope. Let's try this one more time. Yeah. So I have size 4 last items, right? Again, last item is 2, right? We peak, right? Again, here we utilize the string method, right? Can we do print wrapper? Let's do. Does the wrapper have anything? Yeah. Wrapper version of my stack, size 4, last item 2. Okay. How about multiplication? Let's multiply things, right? How about multiplication? Triple stack, right? Right. And of course we have slice 6, right? And last item is 2. Yeah. So again, very convenient because again, very flexible. You can define whatever, it depends on your language, of course, right? And here in Python, right, you can overload. Typical thing is overloading operators, right? Again, you could also remember C++, it was kind of, you could do the same thing, but of course the language, the syntax was kind of painful, right? We'll see in Kotlin, it's interesting, in Kotlin, you can extend any class, actually, kind of cool. You can, even the ones you don't own, you can actually extend things you, add something on top of somebody else's class if you want. It has some limitations, but it's kind of interesting, right? So it's one of the big kind of selling points of Kotlin. Okay, so instant methods, variables are the most commonly used, right? So every object of class has its own set of instance variables, but also, of course, there's a possibility of something called class or static variables, right? There's class variables, static variables, right? Kind of things where it starts getting kind of complex again, right? Because I think by now, most of you, I think, pretty comfortable with the class as a blueprint, object as an instance, right? That part, I think, kind of, right? Or no? That part is okay, right? But when you get to this class variables, right, on instance variables, right? So static methods, or instance methods, not so clear, right? For example, but of course the issue is how much data you want, how many copies of data you want, basically, right? Because usually, by default, in most OOP languages, when you make an instance, you get everything for yourself, for that object, right? You create an object, it gets a copy of the methods, gets a copy of data and everything. But sometimes you might want to have some shared state, some shared data. Or maybe you don't need methods for, you don't need the extra copy of method. Maybe you can sort of like, be economical, right? And use just the blueprint methods from the blueprint, right? So let me see if I have an idea of this. Yeah, so, because here's an idea. So yeah, so there's two. So this is an option. Again, most languages don't force you to do this, right? But what you can do is, here we use something called the decorator. We are using so-called decorator, right? Again, yeah. So static method. So what's the idea of static method? So this means basically only class will have it. Basically, everybody else will be using the same copy, basically, right? So instances will not have the add method. Another interesting thing is you can start using, since it's already defined in the blueprint. It's kind of like analogy would be if you put a calculator next to a blueprint, right? All right, you have a calculator object next to the blueprint. If you go to you're building a house and you have something you can use on using the blueprint, right? But if you copy this blueprint to an actual house design, you will not have the calculator anymore. You have to go back to the blueprint calculator. Maybe, I don't know, this analogy works, maybe not. Okay, so class method, right? So, yeah, so circle area, so we have this class method, right? So this idea is that we'll class itself, not the object, yeah, not the object. Yeah, so very kind of interesting idea here. Well, let's see how this works. Right. Yeah. Yes. Well, again, if you get, I'm not teaching you Java in this class, right? You know what's the name? Static, but yeah, but generally it does refer to the idea that it's set in stone, but static. It's Java is just like C++. It's a pretty big language, right? So, so in this instance, it's used as to refer to the idea that this stays set. Yeah. Okay. No. Yeah. Yeah. So who writes Java these days?
Not anymore, but previously.
Yeah. Yeah. Write Kotlin instead. It's better Java. Yeah, Golang is good too, of course. Right, of course, different thing, of course, right, so.
I've read Java for work a little bit.
And you can't choose.
It's just how it's like for a website.
Yeah.
Extra.
Yeah.
A really old one,
So yeah, you don't have, it's already built that,
Yeah.
so it works, right, you know, you're part of the process, right, and you have to use, I mean, but the thing is, that's kind of thing about Java. Java is kind of like C++, the boss. They kind of like, I'm sorry, like, I don't know, Republican or Democratic Party in America, right? They accumulate ideas from other parties and then they just kind of absorb them, right? So they have everything in the kitchen sink now. I mean, Java has lambdas now, right? And has other things too, right? But you're probably using old version of Java, right?
Yeah, extra. It's like 10 years old.
Okay, that's relatively young. For Java, right, you know, Java versions, right? It's like 30 years now already, right? So, right, so we go to Java 8, for example, still widely used. It's actually supported up to December 30th, right? Java SE 8, right? 7 sometimes used, right? And of course, these are really old, but still around. And so, but of course, you should be using latest LTS version, right? Java 21, for example, be what you should be using. But of course, and this is coming up soon, right? But 17 is actually, I think, default is 17 now, and at least on Ubuntu, 17 is default, right?
I use Java 1.8.
1.8?
Yes.
Oh my God! Right?
It's
Yeah, yeah. But yeah, but again, no. You see, but it is still supported technically.
yeah.
That's the thing,
Yeah.
you know. And even there's some what is this Bellsoft Liberic? Bellsoft is actually like a phone company, right? They are beating everybody. They say they're supporting it till March of 2031, right? That's pretty impressive, right? But yeah, so that's the thing. Yeah, so that with Java in general, right? You want this robustness, right? The supports, you know. It's almost impossible to upgrade, right? I mean, again, because you have to justify why would you want to upgrade. Like just using lambdas would not be a good reason, right? Or using some new cool constructs, right? So, but yeah, okay. But let's go back to our example here. I mean, I could talk about this a long time. So static method and class method, right? So idea is this here that we don't duplicate the work, right? It's already built in the class. On what do you gain with this, right? So we don't have to, you see, we can use it. Let me run it, right? I can use it immediately, right? Before any objects from the blueprint, right? So I can get my pi out, right? It's already available, right? So I can use it as a calculator. So, okay, so you might be asking, okay, so what's the point of that? Why would you want to do this, right? Well, what do you gain? You gain namespace, right? You have this my mass. It's kind of like building a library or something like that. You could stick everything there, right? And start using. In fact, that's how it's done in many libraries, right? You stack it on a class, right? You stick it on a class as a static method or static data, basically, right? And you import this library and you start using it immediately. Sort of bypassing the need to make objects. I mean, of course, but you can still make. I can calculate circle area. So again, circle area, right? It's a class method. So what's the difference between static method in terms of Python? Static method and class method. What's the difference?
That's what I wanted to ask you.
Okay, right. You see the difference here. First of all, you see the CLS, right? In fact, of course, as you know, in Python, I could call this myself or this class or something like that. Yeah. So you can call it as you know, Python is so liberal, right? You can call it whatever you want, right? But of course, CLS is like the default. So notice the difference. Add does not have that. So add is basically, it does have no access, does not have access to the class data. So difference is here, all right. So notice, no difference. Note the difference between static methods. Yeah, so that's what I was saying. That's the main difference, right? So that's, yeah. So if you have some data, constants, or maybe you could have, of course, also a shared list or shared data structure inside, right? I don't know, something like, I don't know, something for what you call, but I've been talking too long, like it's like 2:50, right? So let's take a break, right? Let's take a break, let me save this. So a static and class method, you understood the difference? Did you understand the difference between static and class method? Between static and class method. Here.
Did I understand the difference?
Yeah.
Yes.
Yeah.
Because of the CLS.
Yeah, you have access, yeah, to the class, all the reference for the class. Yeah, which could be other methods, could be anything, right?
Yes.
Yeah.
Kind of makes sense, but
Yeah.
feels,
But again,
in Python terms, feels
Yeah.
a little bit stupid.
yes. No, its thing is, of course, you of course, again, doesn't cost that much extra memory. You could keep it, this, you make it for the objects, basically, right?
Yeah, of course, but
Yeah.
Python is usually the one that doesn't make separate
Yeah.
spaces.
Because,
Kind of.
yeah, in Java or some other languages you do this, but in Python it's so loose already, so it's, kind of feels weird a little bit.
Yeah.
Okay.
Yeah,
All right. Okay, let's take a break.